Hi Logic students, in this video I will give you some examples of symbolization with this new language that we're using in chapter 7. Let's look at a couple of simple examples and then we'll do things that are slightly more complicated. Imagine that I want to say everything is beautiful. What does that mean? Well, from a logical standpoint, you could say that it means that for any given thing that you may take, whatever that thing may be, that thing turns out to be beautiful. That's what you are saying when you say everything is beautiful. We're not talking here about whether this statement is true or false. We're just trying to get to an understanding of what a person would be saying if they were saying that everything is beautiful. Somebody who says everything is beautiful is basically making the claim that you could take anything whatsoever and that thing would turn out to be beautiful. So it makes sense to symbolize this as for all x. So taking anything whatsoever, that thing x is beautiful. So for all x, bx. Remember that, as I mentioned in the previous video, the variables and the constants go to the right of the letters that represent properties and characteristics. In this case, the property of being beautiful. Okay, so if you wanted to say, any kind of statement that has this form, everything is whatever, everything is blank, then you would use this kind of structure. You would simply change the letter for the property. If you wanted to say everything is interesting, then you may do for all x, x is interesting. So it's important to maintain the same structure. How do you do something is puzzling? Something is puzzling is done in a similar way, only with the existential quantifier. You will say that there is an object, an unspecified object, and that object is puzzling. So you would do this as there is an x such that x is puzzling. There is an x such that px. And again, any statement with this form, something is interesting, again, you would do there is an x such that x is interesting. Okay, so these are the most basic statements about everything and statements about something. But the more interesting statements from the standpoint of logic are the ones that we studied when we were doing categorical logic, the four basic types of categorical propositions. I'm sure you remember those. The A proposition, so universal affirmative, something like all dogs are mammals. The E proposition, the universal negative, something like no dogs are cats. The I proposition, so the particular affirmative, some jokes are funny, for example. And the O proposition, some people are not French, it's the particular negative proposition. So these are the most important and interesting logical propositions when it comes to categorical logic, so we need to know how to symbolize these. And it's interesting that you can think of them in groups. Of course, these two are universal. So you will use a universal quantifier, and these two are particular. So you will use the existential quantifier. So the upside down A for these two, and the backwards E for these two. And the universal ones are represented as universally quantified conditionals. So conditionals, remember, if then propositions that have a horseshoe in the middle, and they're universally quantified. They have a universal quantifier in front of them. Whereas the particular propositions are represented as existentially quantified conjunctions. So conjunctions, statements where the main operator is and there is an existential quantifier in front. You'll see that it's actually quite intuitive. If I want to say all dogs are mammals, what do I mean? Well, from a logical standpoint, I mean that you can take anything whatsoever, and if it is a dog, it will turn out to be a mammal. So the natural way to symbolize a universal affirmative proposition is to say, for all x, if x is a dog, then x is a mammal. For all x, if dx, then mx. It makes sense. All propositions that have this form, that are universal affirmative, are symbolized in this way. So if you wanted to say all sharks are fish, you will go for all x. If x is a shark, then x is a fish. And that would be your symbolization. Okay, so you would see that, after a while, it will come natural to you to think of all dogs are mammals as for all x, if dx, then mx. How do I do no dogs are cats? Here the complication seems to be the negation. But what you can do is simply make another slightly different universally quantified conditional. If you say that no dogs are cats, what that means is that for anything that you may take, if it is a dog, then it's not going to turn out to be a cat. So to say no dogs are cats means that you're saying for all x, if x is a dog, then it's not the case that x is a cat. Right? So it's a similar structure, only of course there is a negation here to signify that for anything in the universe, that's what the universal quantifier says, you can take anything. If that thing is a dog, then it's not going to turn out to be a cat. No dogs are cats. So remember, universally quantified conditionals for the A proposition and the E proposition. Now let's look at the particular propositions. Some jokes are funny. What does that mean? It means that there is something such that it is a joke and it is funny. So you'll be using an existentially quantified conjunction for this type of proposition. Some jokes are funny is represented as there is an x such that x is a joke and x is funny. There's an x, again, such that jx and fx, something exists that is both a joke and a funny thing. And how do I say some people are not French? Well, in a similar way. You will say that there's an x such that it is a person, but it's not French. So you simply represent it as there's an x such that x is a person, and it's not the case that x is French. Okay, here I use the same letter, but obviously it has a different meaning in the two symbolizations. In the I proposition that I symbolized here, F, means funny, but in this other proposition, the O proposition, it means French. Okay, so I hope that this is clear. A lot of propositions, of course, fall into these four types here. So there are all sorts of different variations, but you'll see that many of the exercises in the book ask you to symbolize propositions of this type, and so now you know how to do it. Universally quantified conditional for the universal propositions, existentially quantified conjunction with and in the middle for particular propositions. I'll see you in the next video. Thank you.